Hey guys, so we're looking at our review from November 1st to November 5th. And what we did this week was we worked a lot on quadratic equations. Okay, that's what we started off with. So standard form of a quadratic equation or quadratic function looks like this. Y equals to ax squared plus bx plus c. And that's so important, okay? This is like our foundation for everything. The a is attached to the x squared, so always remember that the a is with the x squared, the b is with the x, and the c is the number that is by itself. So let's do a little bit of practice of that before we move on. Identify a, b, and c from these equations. Go ahead and pause the video if you want to try it by yourself first. Otherwise, let's go ahead and get started. Remember, we said that a is the one that's with the x squared. So in this equation, my first one, with my x squared, we're looking at the number that's in front of the x squared, and we had always said that if we do not see a number, there is an imaginary one there. Okay, b is the number that is with our x, and be careful here because we have to take the sign with it. So b is going to be -3. And then c is the number that is by itself. And in this case, we have a +4. So this was one of the easier ones, right? Because we have it already written in standard form. It's in order. We're just looking for the coefficients. Now, b and c are a little bit more complicated, but let's see if we can do them. For b, our a value, which is in front of our x squared, is going to be 1. The other thing I know is that I have a -4, and that's by itself, right? There is no x value attached to it, so that's going to be our c. And notice I do not have an x, right? There's nothing for me to highlight that's green. So we're going to say that our b value is 0 because we do not have any b's. I mean, we don't have any x's. So we don't have a b value in front of an x because there is no x value. Knowing that, see if you can do c now. Alrighty. Let's start off with our a, b, and c. So I know I have an x squared value. That's going to be highlighted for me in purple. In front of that is going to be 1. The other thing I have is a 2x, okay? So this 2x, there's an x with it. That is our b value. So in front of the x is a 2. And there is no number that is by itself, so there's nothing for me to highlight. Our c value is going to be 0. Alrighty, this is a quadratic equation. The next thing we did this week was we learned how to graph them. Okay, so when you graph a quadratic equation, that is called a parabola. And this is what it looks like. It's a U-shaped. So we have different parts of our parabola. The vertical line that cuts our graph in half, or parabola in half, is called our axis of symmetry. And our parabola can look, like happy, or it can look sad, like this one. And this is still our axis of symmetry. Okay, they're just two different versions of what a parabola can look like. So one on that side, the happy side, and then the sad side. And then the point where a parabola changes direction, that is called our vertex. Okay, really important for us to know these parts. Now, look at the happy one, right? So I'm going to look at this left side, and I'm going to call this side, this is our happy parabola. And this is our sad parabola. Because this one makes a smile. So if you go like this, that's a smiley face. And then if you go like this is a sad face. Okay, so our left side, we have a happy parabola, and we call this like a positive parabola, and that is determined by the a value. So what we did above here, if the leading coefficient, which is our a value, is positive, then our parabola is going to open up like a smile. And the vertex will be the lowest point possible, making it a minimum. Okay, so the other way, if our leading coefficient, which is our a value, is negative, then imagine your parabola is very negative, it's sad, so your graph is going to open down, and that'll make this point, the vertex, a maximum. Let's go ahead and practice working with these. The next thing we did was we tried to find the different parts of our parabola. So first we had to, let's take a look at the example, see if you can identify A, B, and C from our equation. Okay, remember A is the number that is in front of the x squared, and in this case I have a 1. Our B is the number that is in front of the x. In this case, I have positive 4. And our C is the number that is by itself. So for this equation, I have negative 2. Let me sketch this first, okay? So notice our A value is positive, which means that I'm going to have a happy parabola. So when I sketch it, our parabola should be like a smile. Okay. I think my Zoom screen just froze for a second. Let me try to reshare that. Okay, so let me go back a little bit. I identified the A, B, and C. And again, I just want to emphasize that because our A value is positive, that's what our sketch should look like. We should picture in our head a happy parabola. Okay, let's find our axis of symmetry. We had learned in class that our axis of symmetry follows a formula, which is x equals negative b over 2a. We do have to memorize this formula, okay? Nothing I can do about it. We have to memorize it. So when we are plugging in, I like to first replace everything with parentheses, every variable, right? So notice how my b turned into this parentheses and my a turned into this parentheses. Everything else stays the same. The negative stays the same. The 2 stays the same. Let's plug in our values. For B, we got 4, and for A, we got 1. If you go ahead and plug this into your calculator, you will get x equals to negative 2, and let's write our answer in over here. That is our axis of symmetry. Okay, so if you're trying to visualize it, let's add this to our sketch. If I drew the line that cuts my parabola in half, like makes it symmetrical, this would be the line x equals negative 2. Let us find the vertex now. Remember, the vertex is a point. So I have the x value, right? The x value is negative 2. It comes from our axis of symmetry. To find the y value in your vertex, you're going to take your original equation and you're going to plug in. So again, I'm doing the same thing, where anytime I see x in my original equation, I'm replacing with parentheses. And let's go ahead and plug in. We got negative 2. Negative 2. At this point, I don't need you guys to do any math. You're just going to go ahead and plug this whole thing into your calculator. Okay, go ahead and practice plugging that in, and let's see if we can get the same answer. If you plug it in, you should get negative 6. Okay, and that is now the y value of our vertex. Let's add that to our sketch. So that should be right here. This is the point, negative 2, negative 6. Sketching is so helpful because now we can answer the rest of the questions. Does our parabola open up or down? It opens up. Does a parabola have a maximum or a minimum? This is a minimum. Our y-intercept of our parabola comes from the c value, okay? So this doesn't come from our graph, it just comes from our equation. Our y-intercept is y equals to negative 2. Domain, we said in a quadratic function. For the most part, our domain is all real numbers. And then our range, this is the one we have to build, and it's kind of fun. So I know range deals with our y values. Okay, so let's start with that. Range deals with our y values. And then we're going to take the y value of our vertex, -6. So now I want to compare all the other points to -6, okay? And we're either going to choose greater than or less than. So take a look at our vertex and look at our graph. Our graph is opening up. So we can say that all of our points are going to be greater than. If our graph opened the other way, then all of our points would be less than. Okay, but because our graph opens up, we have greater than or equal to -6. Alrighty, and the last thing we did that week was we practiced graphing our quadratic functions. So the first thing we want to do when we have our equation is we want to find the axis of symmetry, and we need to first find our a, b, and c value. So a is -1, b is -2, and c is +5. Remember, our axis of symmetry is x equals -b/2a. Let's go ahead and plug in negative parentheses over 2 parentheses. This is why it's so important to use parentheses, okay? Because otherwise it gets a little confusing. -2 on top, -1 on the bottom. Go ahead and enter this entire thing into your calculator. We end up getting x equals to -1. Okay, that is our axis of symmetry. We now want to find our vertex. So our equation was y equals -x² minus 2x plus 5. If I want to find the y value, I'm going to replace all my x's with parentheses. And we are plugging in -1. Okay, so be really careful with the negatives here. But again, if you just draw your parentheses first, it is not an issue. Okay, not an issue. Go ahead and put this into your calculator. I do believe we get 6. Let me double check. This is -1. No, we don't get 6. Sorry. This is -1. I don't have a calculator right now. Plus 2. Oh, we do get 6. Y equals to 6. Okay, so our axis of symmetry is -1. Our vertex is at the point -1, 6. We're going to put that in our middle. And let me actually just put this in here since we're filling this in. And now to get all your other points, you want to take your calculator and plug this into your calculator to get the other points. Remember, in order to do that, the first thing you're going to do is press y equals. So I'm going to go to y equals, going to enter my equation, -x² minus 2x plus 5. I know you can't see it, but I'm doing it on my calculator right now. Once you enter your equation, you're going to press second graph. Okay, to do that, and if we do that, we get our table of values. Let's take a look and let's copy down the other values for this chart. So on top of -1, I had -2, which gives us 5. And then we had -3, which gives us 2. 0 gave us 5, and 1 gave us 2. Alrighty. Let's go ahead and graph these points. So our vertex is at -1, 6. That goes over here. And then let's graph our other points. -2, 5. -3, 2. And then I have 0, 5. And 1, 2. Actually, look, my graph looks really small, so I think I can go ahead and plot the other points too. Let's see if I can find more points on my calculator that will fit. I noticed the point 4, -3. So let me keep going here. 4, -3 also fit. Sorry, -4, -3, -5, -10. And then we also have 2, -3 and 3, -10. So let's go ahead and graph those as well. Okay. So -4, -3, and -5, -10, and then also 2, -3, and 3, -10. If you connect these, it should give you a U shape, okay? Really, really important that up here, we don't make it pointy, okay? So if you go like that, that's not okay. It should be a little bit bendy, like that. U shape, not V shape. Make sure you draw arrows at the end. That is how we graph, okay? We graph using our calculator. Our domain for this function, this quadratic function, is all real numbers. And our range, we are going to build it. Our range is our y value. At our vertex, the y value is 6. Notice our graph opens down, so all of our y values are going to be less than or equal to 6. That is all. Thank you guys for watching today. I hope this was helpful. If you have any questions, feel free to comment or ask me in class. Bye. If I can stop this, bye.